So we are sketching this thing here called hyperbolas. We're going to generate them from the start, and then I'll quickly show you how to do things quickly. If I substitute x equals 0 into here, what y value am I going to get? Undefined. Very good. Because you can't have a 1 or 0. What does that mean? At x equals 0, you have an asymptote. Yep. At x equals 0, this is x equals 0. It's on the y-axis. It's x equals 0. If you substitute a 1 into here, it's 1 over 1. What's 1 on 1? 1. So 1 and 1 here. 2. What am I going to get? 1 and 2 half. So at 2, it's a half. At 2, it's a half. At 3, it's a third. 3, it's a third. Getting closer. At if it was 4, it's quarter. Okay. Let's go to the negatives. Negative 1. 1 over negative 1 is negative 1. So negative 1, negative 1. Okay. And for the negative 2, 1 on negative 2. It's negative half. So negative 2, negative half. Negative 2, negative half is about here. 1 on negative 3, it's negative 1/3. So negative 3, that's a negative third. Getting closer to 0. Likewise for negative 4, it's negative 1/4. And negative 4 is negative 1/4. Now, if I did, let's see x equals half. X equals half. That's 1 over half. How many halves are in 1? 2. So half 2. Notice at half, I'm at 2. See what's happening there? It's just climbing. What's going to happen is, either way, that's getting closer to 0. And the more fractions we get, okay, the more fractions we can fit in, that means that increases exponentially.
It's still a function. There's no crossover.
Yeah, no crossover. That's right, Tim. In the same way, this thing, if you keep going negative, Arita, you're going to get closer and closer to 0, but not at 0. And the same way as this is going straight up, this is going straight down as well. How many asymptotes do we have here? We don't have 4. Got 2. Because when you do your SAT, you must tell me where the asymptotes are. X equals 0. Yeah. Okay. And y equals 0. I actually haven't looked on the SAT properly. So, listen carefully. When you're doing hyperbolas, you are looking for the asymptotes. What can't x be? 1. So we look for x equals 1, and automatically you put your asymptote x equals 1. The other asymptote that appears, Hudson, you're right over there? Is a positive 3. Okay? So a normal y equals 1 on x goes like this in here, which means there's an asymptote at 0. We're just shifting that asymptote up by 3. So you look for 3. And that's your second asymptote right there. But then we got to start putting some points in. Okay. The best way to think about this is you want to find dots that give whole values. For example, x. What could I make x be so that this whole thing is a whole number? Okay, x equals 0. Zach has gone for x equals 0. Because when we do our working out, we have a whole number at the end. So 0 and 1. So we look for 0 and 1, which is right here. X equals 0, 1. Okay? Now, let's look also on, you can see our curve is in this quadrant here, and it's going to be up here. So we're interested in numbers from 1 above 1. What's another nice number that I can substitute in here so that that's above 1 and gives us a nice number to plot? What can we substitute in? Let's try 2. Y equals 2 on 2 minus 1. That's the substitution. Is 5. So we're going to put 2 and 5 in. So 2 and 5. Shh. Listen carefully. Now we're gonna do Truncus's next class. We're just gonna do a bit next week, but just to end off, it's a really good technique to think ahead of what values. You don't just put random numbers, because you might end up with fractions that might be a bit hard to plot. In this case, we picked good numbers that ended up being whole numbers, because those numbers we can plot nicely on here. Okay? And if I put another one here, let's do x equals 3. Just to finish up. I've got 1 minute. What happens at x equals 3? 2 on 3 minus 1 plus 3. 1 plus 3 is 4. 3, 4. 3, 4. I'm not asking you, lastly, to do every single dot in there. All you need to do, grab 2 dots in this here and 2 dots in here so that you can look at the curve, or at least the intercepts. These two are curving that way. And if we were to do more, whoops, they would curve symmetrically across this line here and down. Obviously, what other thing do we really need to be specific about of labeling? Okay. Asymptotes, which we already have. What's missing from this graph here that we haven't explicitly labeled? An x-intercept, thank you, Tim, which is here. And if you were to do that, what are we going to put in up here? If it's 0, this becomes 0. And you go for it. Backtrack, +3. Bell's going to go 0 minus 3 equals 2 over x minus 1.
Announcement for lunchtime. There will be training in Stadium 2 for Year 7 and 8 baseball teams. That's Year 7 and 8 baseball teams in Stadium 2 at lunchtime today. And could Harry Kogler please come to the general office?
It's 1/3. Should have been about here. Okay. All right.